Hi folks, welcome to another Wednesday Widget. I want to start off by saying thank you. This is Wednesday Widget number 27. That means last week's was 6 months or half a year. Really cool. YouTube really pushes you to do regular content, and I didn't do that back in New York, and I've now sort of realized it does make sense. It keeps the videos coming out, and I think it's cool that there's been a pretty good amount of enthusiasm around Wednesdays and what comes out with the widget. So I appreciate you guys supporting me along the way and watching these videos and getting excited about the widget. Today's widget, we're going to talk about SprutCAM in a different way than normal. I love machining. I love CAM. I love trying to figure things out and really dive into it. It's what I really enjoy. Not everybody does, and not everybody has to. It's part of the awesome era that we live in is you can get a machine like the Tormach and you can use CAM software to get parts made. And at the end of the day, it's something I've talked about in my quoting video. What are you in the business of selling? Most people that, or I shouldn't say most, many people that buy a Tormach just want to make their parts. They don't necessarily care or have a love of optimizing toolpaths and really diving in. Many people do, don't get me wrong, but it's a question again of what's the goal at the end of the day. And like it or not, in 10 or 20 years, you got to wonder how much CAM knowledge is going to be relevant for guys like us. Sure, maybe volume, high production, high precision machining will still rely on that art of a user's input with experience. But you can sort of see how as computing power and software increases, there will be more ways to automate the CAM process, especially for quick parts. And that's kind of what today's video is. I realized this a few months ago, which is I've now started with a SprutCAM sort of template where I have 2 operations. And a lot of times those 2 operations will get me a lot of the part that I want. Now this isn't an end-all be-all. I'm not advocating that you don't need to worry about CAM anymore. So please don't jump down my throat on that. But for folks that are new to machining or new to Tormach or new to CAM or don't care about CAM, and that's okay, my thought is this is pretty cool. Here is a roughing water line and a finish water line that does a pretty good job of getting a part made. Of course, caveat emptor, it doesn't work with things like holes, or it will work, but you've got to add an extra step. We'll get into that. But it's been a boon for me because, as I talked about again in that video on how I quote CNC work, it's tough to be competitive as a job shop. I think one of the reasons I do okay is I'm really fast with a computer. I can bang through stuff. I can work at home or at night with LogMeIn or remotely, and SugarSync keeps all my files. So anywhere I am, I mean, heck, I'd be waiting for 10 minutes somewhere at a lounge and I'll pull up a file and I'll quote work, or I'll work on CAM or things like that. It's just something I'm good at. But the key is to be fast and efficient. And I talked about it in the part we made just last week, the motor clamp, where I'm not going to spend the time to optimize the toolpath. I don't care. I want to minimize the risk. I don't want the part to be ruined or a tool to be ruined, and I want to get it done. And if that means the cycle time is 8 minutes longer, I don't really care because I'm not going to be standing at the machine anyway. I'm going to be off doing something else. Yes, on production runs, we will spend a huge amount of time optimizing the toolpaths. So what I want to do today is walk through, this was actually a soft jaw that I had to make a few weeks ago. I don't want to recut the soft jaw, so we're just going to cut a piece of aluminum. And I added a couple little things just to kind of show it off for fun. But walk through a real quick SprutCAM on it, like really quick, and then we'll make her on the Tormach, and I'll post the files on the NYC CNC website. So hopefully this is helpful to you guys. Let's dive right in. Here is our part. So guys, you need to get paper and pencil ready. Be prepared to play and pause and rewind a lot. This is really complicated. It's a simple part. It's a set of soft jaws. I buy these from Monster Jaws. If you're interested more on soft jaws, I've got a couple of videos where I use them. They're phenomenal, indispensable in the shop, and make a couple different cuts here. So let's make this part. We're going to click Export to SprutCAM. It's going to import itself in SprutCAM. And we're going to go into machining, and on the roughing water line, we're going to select this as our, delete that old one there, select that as our bottom level, and clear out this one as well, and select it as the bottom level. So we basically told it, I don't need to machine below this ledge. These are soft jaws have these holes on them already. So the geometry that we need to machine is, you know, this shelf here, this inlet here, this here, that here, and we're done. Pretty amazing, right, folks? Yes, that's a simple part, but still, I think it's amazing. Now, this is not a catch-all. This is not, you mean you can be an idiot. Don't call me or email me that you crashed your mill or your tool or your part. You still have to think. You still have to watch the simulation. But we'll take a look here. We're going to start out with a 1/2-inch carbide roughing end mill. It's going to come in there. It's going to start taking the first cuts it needs to do so it doesn't increase the chip load too much. Now it's going to, we'll go back through the cut settings actually. Cut it comes down, cuts a little bit more, basically roughing all this stuff out, and then switches to the finish mill, and it takes a pass. I'll explain that in a second. You see there's the 3 passes, and then it should come down here and take the last. So the reason it took 4 passes is it takes a pass for that height plane, pass for that height plane, and a pass for that height plane. Again, it's not the optimized toolpath, but who cares? You made cam in like 5 seconds. And if you look in the parameters, I only have a depth of cut set as 1, but it can't cut it in 1 depth of cut because it has to come through obviously at the different heights. Same thing on the roughing. We'll take a look here. For me, it's tool 11, which is a 3-flute carbide roughing end mill, which you're about to see in a second. 2800 RPMs, 15 IPM. And we don't have to set this stuff. We set the bottom level over here already, leaving 10 thou, and I'm not letting it cut deeper than 1/4 inch at a time. And I think, yeah, I didn't even change that to 50% to how far in it can step. On the finish, it's tool 100. It's a 3/4 inch carbide end mill, 5110, and nothing. I mean, I don't even think I changed any of these settings. So again, we got our toolpath there, and rapid simulate through the whole thing. Boom. Let's go make some chips. Okay, we'll use our Heimer to set our Z0 as I talk and try not to break the tip. I've had a lot of requests for both the Heimer, that's your X0, and how I do the tool table stuff. So I will do a video on that here in the next, say, month or so, folks. I do love this Heimer though. Okay, Y0, and let's set our Z. Z should actually be on. Yep, I was within 3/10, and that's plenty good. Okay, we will switch out to the Merit Tool 3-flute carbide rougher here. Here's a closer look at that tool. I've been working with a filmmaker, and it's really helped me with the videos, although I'm shooting this one solo, and he had this idea of sort of zooming in and filming the tool like this to show it off, and it's really a beautiful tool. I've gotten great tool life out of them. They're not cheap, they're about 50 bucks, but I would buy them all day long at that price because they're just one of my go-to tools. And as you guys see, I did a video on this tool in detail, but it's the flutes that really help minimize chip load and evacuation and lots of good things for roughing. All right, let's rock and roll. You guys saw, if you watched the coolant video, there was some slow motion footage, which was really awesome. And in that slow motion footage, you can actually see the coolant drips from the trico coming out, which I thought was really cool and helps explain a little bit more what minimal quantity lubrication is. Obviously, if you're doing something like this, you need to still have your wits about you and remember that, for instance, you need to make sure your tool is long enough so that you don't crash the tool holder in your part because you're trying to mill something too deep. So little movements like that are by all means inefficient, but again, no big deal in my opinion. One of the nice things I like about this rougher too is I don't mind running it unattended in the shop because it's such a distinct sound pattern that the instant I hear any sort of like chip load or something off on it or too deep of a cut or anything, it is so easy to pop over to the mill and look at what's going on, and I like that. And sure, you can do that with a lot of tooling, but there's something about the way those corn cob or roughing flutes cut that make it, for me, very easy to listen to the tool. I've gotten to know it really well, and that's what's really fun when you've spent, you know, I don't know how long, probably 3 or 4 years using this tool a lot. It is good to know, and actually this specific tool is the reason I hadn't to date bought a tool changer, because I used to make a production run on a part in pretty high volume, and this tool did a lot of the heavy lifting. It was about a 30-minute cycle time. It was, I think we fit 30 or 32 pieces on the full Tormach table. Not something I ever did a video on. And if the coolant lines were not perfect, this tool would chip load. And that's not a fault of the tool, it's because I was really trying to push it as hard as I could and get as much material removal as I could. And without, without being there to adjust the coolant line, I didn't want it to automatically change tools. It didn't do me any good. I'm not as worried about that for a bunch of reasons now, and one of which is that I'm actually having fun thinking about a way to build an automatic or Arduino-based DIY coolant nozzle aiming system. I talked about it in the coolant video, and I think we're done. Yeah, let me grab the other tool. This is a little bit of a longer end mill than you may need, but I've gotten in the habit lately. I used to not pay as much attention to end mill flute length, broadly speaking, and I've gotten in the habit now where I basically try to buy pretty stubby, shorter end mills for the most part, knowing that as a general rule, I don't use more than, say, like a 1/4 inch of the cutting face for most of the stuff that I do. And then when I need something, blow off this part real quick. When I need something long like this, I know I'm not going to have to take an aggressive, width of cut. So I'd rather have one tool like this, high quality tool that I know does a great finish. I've got a really long length of cut on it. And then for the most of the stuff now, I've switched to like, 1/2 inch, maybe a little bit more cutting length. Actually, one of the tools I wanted to try out was Lakeshore Carbide. I think they call it the Firefly maybe, or something stubby, but it's supposed to be great because when you cut those flutes into carbide, you're giving up rigidity. So having solid carbide down to a shorter cutting flute, for me, is probably a good recipe. Anyways, I was talking about the Arduino thing, but I'm playing around with some ideas to make a little Arduino-based thing that'll adjust my lock line nozzle up and down for anything from cutting like this to deep drilling. Who knows how it'll work, but it should be a fun little project. So I could probably be going a lot faster here, to be honest with you, but again, just taking it easy. And again, the point here is it's hard for me to, sometimes it's hard for me to let go, but the point was not to become a cam expert here. The point is, how little can I do and have an acceptable part pop out, which is pretty cool. We'll fast forward through the rest of this here, and we'll take a look when she's done. Take a look at that, folks. Pretty cool. You saw at the end, I grabbed some of these chips into my hand. Long, stringy chips. That's really, I'm trying to focus more on that now. That long end mill is not what you would do for a traditional, any sort of a high-speed machining or deeper depth of cut, thinner width of cut, because it doesn't have as much rigidity, but it's nice to see a nice long thin chip like that, and pretty darn good surface finish. Let me take it out of the vise here, wipe it down, and we'll take a final look. Look at that, folks. I think that's pretty flippin' cool. Heck, you can almost, you can't see my reflection of my fingers. Look at that. Look at the fingers in that cut quality. Pretty awesome, right? So this video is not going to be for everybody. I get it. There's still a huge role in cam and learning cam and being efficient, but for the job shop guys out there, consider having a template file like this that you start off with. And for the folks out there who just want to make parts with their Tormach, they don't need to be in a pissing contest for CAM skills. This is great. Seriously, run with this kind of stuff. So with that, folks, I hope you've enjoyed this Wednesday widget. I appreciate your viewership. I appreciate clicking the thumbs up, commenting, sharing the video with your friends, all that good stuff. Take care. I'll see you next Wednesday.